Alright, we're working on 11.2.3, completing the square. Alright, we're going to jump right on into it. Alright, so question 1 is then completing the square form. Like they've already completed the square. Once we get to this step, how do we solve it? We did this a little bit last section. I'm going to square root both sides. When I square root a number, I got to make it plus or minus. So this becomes x minus 3, because the squared got canceled, equals plus or minus square root of 5. I then want to get x by itself, so I add 3. X equals 3 plus or minus square root of 5. These are what a lot of your answers are going to look like when we're done with completing the square. Alright, so let's get into question 2 and how we actually do this. Alright, so complete the square for x squared minus 6x equals 5. So first thing I want to do is make sure my two x terms are on the side by themselves. So I have x squared minus 6x. And then I take my b term, which is right there in front of the single x. And I got to do b divided by 2. I don't know why. There we go. And we're going to do b divided by 2 squared. So I need to take negative 6. I need to divide it by 2, and that's negative 3. I then need to square, and that's 9. So what I need to do is I need to add 9 to both sides. Alright? So the left side will be x squared minus 6x plus 9 equals 14. And whenever we complete the square, the next step is super easy. And I'm done. How did I get there? How did I get to this point is we are always going to be in the form x plus x minus. It's going to be x plus or minus b divided by 2 quantity squared equals whatever your constant is. So I just know once I get my trinomial here, I can just do this shortcut over here, take that b term, that negative 3, which I already actually solved, and that becomes my factor. So I had to take the b term divided by 2, square it, and I had to add that number 9 to both sides, right? Because if I don't do it to both sides, I'm not keeping the equations equivalent. Then once I get the trinomial, I can then take that trinomial and put it into this form, because I know it's going to be in the form x plus or minus b divided by 2. Nice little shortcut. Alright. This one, because my leading coefficient is not 1, I can't complete the square. But what I can do is divide everything by 3. And this gives me x squared minus 2x equals 7. Alright, now I have a leading coefficient that's 1. I can complete the square. So I'm going to take the negative 2, I'm going to divide it by 2, and then I'm going to square it. So I got to add a 1 to both sides. Then here becomes x plus or minus b divided by 2 squared. Well, what's b divided by 2? It's just negative 1. There, I'm done. Take the b term divided by 2, and that's it. Oh, we want to solve the equations by completely square and solve for x. Okay, we can do this. So this is going to be, well, negative 6 divided by 2 squared is going to be 9. So I'm going to add 9 to both sides. Then I know this is going to become x minus 3. And now they want us to actually solve. So the only step we're going to be adding when we solve is the square root. Got to put that plus or minus. So we have an x minus 3 equals plus or minus square root of 21. The last step is I add 3 to both sides, and I get x equals 3 plus or minus the square root of 21. That's it, I'm done. Now we could plug this into a calculator. 3 plus the square root of 21 is one answer. 3 minus the square root of 21 is another answer. If they ask us to do that, that's an easy calculator plug-in. But I'm cool with just leaving it like this. it's kind of proper. I'm not going to go ahead and do 5. I will say that before we go through all my completing the square steps, the first thing I would need to do is divide by 2, right? Because the leading coefficient isn't 1, so I couldn't complete the square yet. And then I can go complete square from there once I get it by itself. Alright, now vertex form is kind of what we've already been doing. Alright, so first thing I'm going to do for this problem is I'm going to subtract the 1 from both sides. So this is going to be y minus 1 equals x squared plus 4x. Do you really need to do that? Probably not. I think you can get away with not doing it. But it's just always a habit that I was taught. So I guess I'll keep it up. I can take that 4 divided by 2 and then I square it, right? So I'm going to have, add 4 to both sides. Add 4. I'm going to rewrite it over here now. So I have y minus 1, or sorry, y plus 3, right? Because it's going to be negative 1 plus 4, so it's going to be plus 3, equals x squared plus 4x plus 4. I know I can change that right side to be an x plus 2 quantity squared. And then for me to get into vertex form, I need to get the y by itself. So I subtract both sides by the 3. I get y equals x plus 2 squared minus 3. This is vertex form. So if they ever say vertex form, that's what they're talking about. This form up here is called standard form, just so they ever ask the difference. That box elsewhere. The function y equals negative 5x squared minus 20x minus 23 can be rewritten in vertex form as y equals negative 5, negative 3. All right, this function opens up or down. Well, one, we can go into Desmos.com and we can plot it and they get this information. I know that this function opens down. Why do I know this function opens down? The negative 5 there, negative 5 there. The leading coefficient, so the first coefficient is negative, that tells me automatically it's going to be opening down. So if it was positive, it would be going up. And then the vertex then would have to be a maximum. So if we open down, it's a maximum. If we open up, it's a minimum. Down, maximum, up, minimum. And then the vertex itself would be at write this formula. This is in the study guide that you have. If you don't have it, just email me. I can get it to you. This is what vertex form is, and we kind of got to it up here, right? That's vertex form. Well, what this is, this H and this K is my vertex. That's the ordered pair of the vertex. So X opposite of H, so I'm going to take the opposite. So this is showing plus 2. My X value is negative 2. And then negative 3. So I just took it. The H is there. It's always going to be opposite. I read this as opposite. And then the K is just whatever the constant is outside. So if I bring it up to this, oh, never mind. This is the same problem that they gave us in question 6. I just didn't notice it. They just added the coefficient in front, which is fine. See if there's any other fun problems here. Okay, so let's do question 9. We'll penguin starts on a slide. Sorry, I don't know why there's 2 of them. He slides down and glides underwater. The function y equals x squared minus 4x plus 3 shows his path, where y is his height above or below the water in feet, and x is the horizontal distance. Complete the square to find and interpret the extreme value, aka the vertex. So I am going to subtract 3 from both sides. I'm going to complete this square, which is that process, which means I have to add a 4 to both sides. I am then going to simplify this using my x plus or minus the b divided by 2 squared. So this is going to be x minus 2 squared. I am then going to subtract 1 from both sides. And I get y equals x minus 2 squared minus 1. Cool. Now, complete the square to find and interpret the extreme value. Well, so what is my vertex? Well, my vertex is going to be, well, the opposite of this. So just the opposite of this is going to be a positive 2 and then just that. So negative 1. So 2, negative 1. What this interpretation means is that when the penguin is 2 feet, right, so this is horizontal distance, when he's 2 feet, horizontally away, is that, oh, from the slide. So, okay. Okay, sorry. I just wanted to make sure I was understanding the question before I started explaining, because I think I was going to say it wrong. So, what the vertex is down here is that the lowest depth that the penguin gets after he slides off the water is negative 1 feet below the water. So he's 1 feet below the surface of the water, and he is 2 feet out when that happens. So he slides down, he's 2 feet away from the slide, and he's a foot deep in the water, and then he starts to glides back up underwater.